Hello everyone. In this video, we will solve this log equation using different laws of log. So the first thing we need to do is analyze this given equation. This equation has three log terms. So there is log of 2 to the base 3, 2 log of x to the base 3, and then there's a log term on the right side of the equation, log of 7x minus 3 to the base 3. Now on the left side of the equation, the log terms have the same base and they are being added. So we can combine them using the product law of log. So I'll write the product law. So the product law looks something like this. So log of x to the base a plus log of y to the base a is equal to log of xy to the base a. So we multiply x and y and the base of the log stays the same. So we can do the same with these two terms. Now the tricky thing here is the second log term has a coefficient 2. Now this law of log is applicable when the coefficients of the log terms are 1. So the first thing we'll have to do is move this 2 from the coefficient to the exponent of x using the power law of log. So I'll write that law on the board. So log of x base a, and if the coefficient is y, so we can rewrite this as log of x to the power y to the base a. So this will be our first step. So log of 2 to the base 3. So the first term stays the same and the second term becomes log of x squared to the base 3, and then the right side stays the same. Now we can combine these two log terms using this product law. So log of 2x squared. So we multiply the 2 by x squared and the base stays as 3 equals log of 7x minus 3 to the base 3. So the right side stays the same. There is nothing we can do on the right side of this equation yet. Now both sides have just one log term with the same base. Now we can cancel out these logs and we are left with just 2x squared equals 7x minus 3. We are able to cancel out these logs because the log terms have the same base. If the bases are not the same, then we cannot cancel out the logs like that. Now we are left with a quadratic equation. So the first thing we have to do is move all the terms to the left side of the equation and set it equal to 0. So we can start by subtracting 7x from both sides. So the 7x is on the right side, cancel each other out, and we get 2x squared minus 7x equals negative 3. Now we can add 3 to both sides. So the 3's on the right side cancel each other out. So we get 2x squared minus 7x plus 3 equals 0. We can factor this equation and then solve. So this is a complex trinomial because the coefficient of the x squared term is not equal to 1. We can use the decomposition method. So we start by finding two numbers whose sum is negative 7 and product is 2 times 3, which is equal to 6. So now we should analyze the product number to find those possible two numbers. So we can do the calculations on this side now. So the first two numbers whose product is 6 are 1 and 6. Now if I add 1 and 6, I get 7, not negative 7. So we should make both of these numbers negative, because -1 plus -6 is equal to -7, and -1 times -6 is equal to +6. So these are the two numbers we are looking for. So using the decomposition method, we will break down the middle term. So instead of -7x, we'll write -1x, -6x. So we have broken down this -7x into -1x, -6x. Now we can pair up the terms and use the grouping method. So from the first pair we can factor out an x. So we are left in the parentheses 2x minus 1. And from the second pair, since the first term is negative, we can factor out -3. So we are left with 2x minus 1. Now we can factor out this 2x minus 1. So we get 2x minus 1 times then x minus 3 is equal to 0. So now the factoring is complete. So this x goes here and this -3 goes here. Now we get two cases. So we set each factor equal to 0 and then solve for x. So for the first factor, we add 1 to both sides. So 2x equals 1. And then we divide both sides by 2. So x equals 1 over 2. So this is the first solution we get for this equation. And then for the second one, we'll add 3 to both sides. So the 3's on the left side cancel each other out, so we get x equals 3. So this is the second solution. Now we have to check if these are valid solutions. So for that, we will sub these x values in this equation to check if these solutions are valid. So let's start with the check. We sub in x as 1 over 2. So 7x minus 3 stays positive. So it becomes 7 times 1 over 2 minus 3. So it will be 7 over 2 minus 3, which is equal to 1 over 2. Now x equals 1 over 2 also works for this x log term. The other log term is a number term, so it's not affected by the x value. So that means x equals 1 over 2 is a valid solution. Now we can check for x equals 3. So if we sub in x as 3, so again 7x minus 3 will be a positive value, because it will be 7 times 3 minus 3. So this will be 18. And for x equals 3, the second x log term will be a valid term. So that means x equals 3 is also a valid solution. So in this case, both solutions are valid. So I hope you'll like this video. Please share it, like it, and subscribe to my channel. Thank you very much and have a nice day. Bye.